Let's discuss Python integration with MemCache. This will provide us a means of scripting access to our MemCache cluster wherever it happens to be distributed. So, Python integration. A number of features exist. For example, this gives us a scripted interface to MemCacheD. This becomes important because it allows us to develop distributed applications so we can spread our scripts across multiple nodes, let's say multiple web servers, app servers, etc., and consult our MemCache cluster accordingly. It supports the standard calls that we've looked at from the CLI using memcat, memccat, and the various memc commands, memcdump, memccat, etc., looking for key value pairs, add, sets, cases, etc. So, i.e., add, set, replace, delete, etc. So it gives us the mechanisms programmatically to manipulate the cache accordingly. And perhaps more importantly, this allows us to distribute our application, so it supports distributed scripts. So multiple nodes, for example. Of course, consulting one cache cluster. So let's go ahead and get it installed. We'll install the Python package. This is within Ubuntu Debian, so it may differ in terms of name on other platforms. And we'll begin with our UbuDesk or client front-end node, as it can talk to the various backends. It's not necessary that we have it on the backends unless scripts are running there. At some point, if scripts are running there, certainly. So for now, let's start with the first host. So we'll just do an aptitude. Install Python memcache. And let's find a window locally. Let's do a sudo aptitude search. Memcache first. And this should give us a list momentarily. So insofar as Python is concerned, this is the package Python memcache. Ditto for PHP. Let's shift this to install. And then we'll have it momentarily. And let's do a package dump once it's completed. And what you'll see is the memcache py. This is the main workhorse. Let's place this into the fold. This carries out the logic. So this provides us with the memcache library connect for Python. That means if you take a look at this file, you'll see some usage information. It gives us sample code on how it can be used. This is your main string. And also standard usage that you'll find online regarding how to use memcache altogether. Let's paste that in so this becomes our template. So perhaps what we'll do initially is begin with the interactive interface of Python, one of the beauties of Python. So use Python's interactive interface to engage with MemCacheD. So for Python, that's simply Python, and then we perform an import of the memcache module, Python module, and that allows us to go to work. So let's launch Python. Now, Python should be installed as a standard on your NIX system. In fact, if you do a which, you should see it's in user bin. So for scripts, just user bin Python and you're good. Let's launch this. So now we're in, but of course, there's no memcache support. So we'll import memcache, as you do with any Python module. And once done, we can then look for additional help regarding the module using help, for example, memcache. And this will give us usage information regarding the various classes, which also includes the standard blurb regarding sets, gets, deletes, etc., incrementing decrementing, as well as all of the various methods that are tied to this particular object. So generally speaking, just like we've used from the command line, the live MemCacheD tools, same functions are available, but of course the symbolism, the semantics are the same, symbolism's different, so the syntax different. So things that you want to do is you need to create some sort of connection object to the cache, just like you would with a database. So that's usually step one after you've imported the module. So import memcache. And this brings memcache library into the fold, into the Python fold. Once there, then we create an object. So the standard recommendation is you create an object that looks like the following. Now our cache is spread across the wire, so we'll have to retrofit this to include those particular hosts. Now, since you have usually no control over where objects or key value pairs are distributed unless you specify grouping, for example, or you adjust the weighting in such a way that's favorable. But generally speaking, your key value pairs will be spread across multiple hosts. It helps that you specify all those hosts for any sort of call to the memcache cluster. So we'll go with the standard syntax of MC memcache client and check the case, of course, because as you consult the documentation, for example, let's take a look with a help memcache. As you see, its references uppercase C for client, and it'll be a problem if you specify a lowercase. So be sure that it's uppercase, it's case sensitive. So memcache.client, and in between our parentheses and in between brackets, we'll define one or more hosts. So because we have 3 in the cluster, we'll specify 3 placeholders because we're not sure as to where our values will be stored and thus retrieved from. So the standard socket specifier is the IP address followed by the port. So that's going to be 110 for the first host, so 11211, and we'll just copy and paste this for the other 2 and retrofit it accordingly. Let's get this into the fold as well. And if you have, let's say, perhaps dozens or more nodes in your cluster, then you could always use some sort of sequence generator if your hosts have IPs that follow one another or names that are incremented logically. So 10, 11, and 12 will be a part of this connection object. This should create the connection object. If there's a problem creating the object because of a syntax error or otherwise, then Python should complain via the module, raise some sort of exception. So now we have the object. That's your equivalent to a connection object to a database. Once the object's in place, and often you put debug equals 0, which is an option here, which we omitted, but that's the default. Once the object is in place, then we need to look for values. So let's see what we can find. Well, we can use, let's say, the get function to pull something from the cache. So let's do MC, that's the object, get, and the name of the key. So we've used this product identifier syntax or nomenclature. So let's go ahead and try to get something such as product 999. Let's see if that's in the cache. And that should return momentarily. You can actually print it directly. So if you say print, and that particular item, if it's in the cache, it'll print. Let's see if something else is there. Now, certainly it appears as if none of the values are available on the remote side. Now, one of 2 things could have happened. Either the values have been timed out on the server or servers, or perhaps there's a discrepancy between the clients. It's perhaps the latter that's a problem. So let's just note that this is an issue you'll encounter a lot. Let's take a look. That various clients use disparate hashing mechanisms to store key value pairs, which is why we wanted to look at some of the front-end clients such as Python and PHP to differentiate them from, say, the lib memCacheD related clients. So let's just note that, for example, lib memCacheD tools related clients store data differently from Python, etc. So how do we show that? Well, let's take a look again. So we've looked for values that we know are on the server. For example, product 999, 1000, and 10,000. So from a separate shell, let's pop another one here. If we use, for example, MemCacheD against the same list of servers, so 75110, 111, and 112, in search of the same keys. Let's go with product 999 first. So there's the value. Let's say product 1000. There's that value, and ditto for product 10,000. So the values are returned. However, Python has no knowledge of it. So the idea is that the mechanisms for storage are different. So any values set by Python will be readable by Python, regardless of where you query those particular entries. And that's reassuring because, again, the presumption is that you'll use common applications which use common hashing mechanisms. However, if your values, your key value pairs, are to be stored across hashing mechanisms, across tools, then you'll want to consolidate them to one hashing mechanism. Otherwise, you'll have problems resolving values. So let's just note that if disparate front ends or clients are used against MemCacheD, ensure hashing algo consolidation. Ensure that they're using the same standard. Otherwise, you run the risk of resolution issues. Otherwise, there will be resolution problems of the key value pairs. So how do we show that? Well, what we should do is set something. Let's go ahead and fmcset. Let's perhaps set something that could be a part of a profile for later usage, such as fname. So let's set fname, let's say, equal to Dino. Simple value. So this will set it, and the subsequent call will be to get it, just to be sure that it returns. But let's be sure that we set it first. It returns true, so that's reassuring. Now let's mcgetIt with its key name fname, and it comes back. But that's, of course, only reassuring for this particular system. Let's confirm it on other systems. So mcget fname, let's just terminate this with single quotes, returns stored value. And let's just note, repeat on remote systems to ensure retrieval. So the idea is that you have a web farm, and we, from our client system, the development box, this box stored items somewhere in the cluster. Right now it's fname on one of the target systems, since single key value pairs are not spread across hosts. So somewhere in the clusters, entries or instances 1, 2, and 3, or 1, 2, and 3, that single value exists. So we should try to query it from any of these items. So we can go to, let's say, ubuserve1 and see whether or not we can get the value. So let's try that out. Let's open a separate window over to ubu1. That's this one here. So if we do a memccp, for example, or memcccat, that is, servers and the whole. In fact, let's just history grep memcct. Nothing's in the history here, but if we try to memccat, maybe we have an instance over in this window. We don't. Let's take a look back at another pop-up here. And this is the lone instance, and this is the other window. So if we take this memcccat and try to dump, let's say, that value that we recently created, nothing comes back. But what if we did a memcdump? So let's change this to memcdump all of the values. So there are all of the values. Now let's grep it for fname. So fname's on the list. It's just unintelligible, which is the point, to the live mcache, or memcache, that is, D related tools. So that's where you'll see differences. Now, insofar as rectifying this issue. So Python we've stored it here. On a remote system, let's install the same library. So we'll sudo aptitude install Python memcache. And then repeat this process for multiple hosts to ensure that they all have access. Because again, presuming that these three systems are web hosts, then the client is likely to execute from any or all of them depending on your traffic flow. So let's try this out here. Be sure that all three have them populated. And on the third one, let's sudo and install that as well. And then we'll be able to enter Python and ensure that the values are resolvable across all the hosts. So let's see what's happening on the first one. So this one looks good. Let's go Python, import MemCache, set our connection object, which is defined in our notes, which covers all three systems. And we'll just use the standard nomenclature MC. And that'll set that. And then do a print mcget fname, which will resolve. So there's the value, and this is from the second host, and you can do a type on it to see how Python views this entry. It's string, and ditto for the other host. Let's go ahead and do that as well. So we'll bring this in over on number 2, so Python import memcache. We'll just remain inside the interfaces for now. Set these items, and then print mcget fname. That's looking good. And presumably the same will work on this one as well. So let's Python this as well. Import memcache and do the same thing. Print MC is the object, get is the class or the method in this particular case. And there's the item. Now from the third one, let's set a value, perhaps last name. So while we have the object open, MC set, for example, as opposed to get, and let's indicate perhaps lname. That'll store the value in the cluster, and let's get it while we're here, so ensure that this host can resolve it, and then let's get it from the other hosts. In no particular order, let's start with number 1, so let's get instead of fname, lname. And let's just double check that. Well, it's type string. We want to print it. So print and changing this. And there's the entry. And on this host, let's just copy and paste this as well. And that should set us straight. So again, the mechanisms are different across the host. So all three, so long as you're within a Python realm, so long as presumably your application is Python, should have no problems resolving the value. However, various tools function independently. And you'll see that online when you look for help concerning MemCacheD. So now values may contain superfluous characters. You can strip them out, apply any sort of Python semantics to them to fix matters. So you set a value, new line, etc. That can be stripped out accordingly. For example, let's say as a set in this third window, this time we set the last name to be, let's say, this n. So it takes the full string. Now let's get it again. Now it includes that new line. That's not desirable. On this side, you're going to see that new line, but you can always, of course, just apply a simple strip function, strip method, and it'll rip that off for you. So once you're within the Python realm, or Perl, or any other, no problems, you can apply any of your values. But the hashing algos differ across various clients, and that's the key. And you can set them to be the same so that the values are resolvable. So it's not that Python doesn't see that the key is there. The key is there, it knows it's there, but it's not able to translate the value as it was stored by memcp or memccp, that is. So what are some other things we can do? Well, you can reduce network latency, for example, by storing, let's say, multiple values at once. So perhaps if let's say we had a number of variables that constituted a profile. It could be fname, last name, email address, and some other items. So that would be something you could do. Maybe you set a variable such as maybe MC set, and it will get it after setting it to a variable such as profile. So let's MC set multi, which we haven't done from the command line, and this uses a slightly different syntax, but nonetheless, now we specify the keys. So key 1, colon delimiter, value 1, etc. And we repeat this for a number of instances as we need them. So for example, if we're constructing a profile, we could set the individual values and then reference them on a get and store them into a tuple or into a dictionary form, that is. So perhaps we have first key is fname, first value, let's say Linux CBT, and then we just delimit this and repeat. So let's say lname, and that's going to be a colon delimiter, user, for example, and perhaps email address. So email. And this is the type of information that when you log on to online boards, for example, would be commonly referenced and perhaps shouldn't be pulled from a DBMS, but rather from the memcache. So let's give it an email of linuxcbt at linuxcbt.internal, for example. And that'll store in one operation 3 values. You can break this list out as long as you need. So stores multiple values in one operation. And let's just note that this reduces bandwidth usage and overall latency. And the converse, of course, applies to gets, whereby you can pull multiple values in at once. So we set this for many hosts. Let's take this in and copy that into our buffer. Maybe we'll start with a second host this time and paste that in. So that'll set, returns just a open and close bracket, which appears to be an empty set, but the values are now set. Now to confirm that they're there, you can use the get multi, which is the converse. So let's go ahead and MC get multi. And then you just specify, using standard form, a list of keys delimited by comma. So for example, maybe we'll start with email, followed by fname, followed by lname. You need not derive all that you've set. Certainly, you pull the ones that you want as you need them. So retrieves 3 values in one operation, for example. Let's try this out. And we should print it, of course, because if you don't, then nothing's echoed. Let's go ahead and paste that out. Actually, it echoes in this case, but it's not stored for reuse throughout your code, which is really the intention. So that's why we should store it in a variable. So it returns these as the dictionary that you see here, so you can pull off the keys or the values. So keys and values, you can list them and so on. So any of the dictionary functions that are supported within Python would work just the same. So for example, let's set this, because we've lost the values, so let's set this a profile, presuming that profile constitutes these entries. And notice that it returned it in its way from lname to email to fname in its order. It can be sorted as needed. So let's reoperate this to be profile is equal to, and let's just know that it stores values in dictionary. That's a Python dictionary, which means you can apply dictionary functions. So now profile is available. Let's do type profile, and it's of type dict. So whenever you have a dictionary, you can enumerate the keys and the values. For example, profile.keys shows the keys, and ditto for values. And again, that's all specific to Python. So L profile keys enumerates keys, which you could certainly loop over, and ditto for values. And perhaps this is the important list of interests as you echo information back to the browser, for example. So maybe internally you have name, or maybe you have both, name, email, or first name, last name, email, so on and so forth. So these are dictionary items. And of course, you can pull out the individual keys by specifying them distinctly. So profile, let's say profile, give me the email, and this will bring the email out, and ditto for the other items, so you can pull them out independently. So, and profile and the particular key returns the distinct key. So for example, email. etc. So you can pull those entries out, and you can also delete multiple items at the same time using MC delete, or the object delete multi followed by a list of items that are of interest to be deleted, so the list of keys. Now again, these values are available across the entire cluster, so if you, for example, do an MC get multi on these on any of the other hosts, we should always confirm that everything's viewable from everywhere. So from number 1 comes back, and number 3 should come back accordingly. And also locally, on our local system, it'll come back as well. So it's in the cache, it's coming back very rapidly, and now all the systems have access to those particular values. Now, what are some of the uses from Python for MemCache in general? Some uses include, for example, sharing IDs, let's say like an instance ID or a session ID. So maybe your front-end Python clients, whatever they're doing, maybe they're running as part of CGI or scripts that are croned, maybe they need to consult the cache for an ID that's set across the board or on a per user basis. So storing that value in MemCache and querying it accordingly is something that's quite helpful. So let's just note common uses include, but not limited to, of course, storage of shared IDs. So, for example, let's say there's an instance ID that needs to be tracked. So you store this in. Let's say you have an instance ID is equal to some number, arbitrarily 4899. Store in MemCache D, and then reference via Python across scripts, and your scripts are run on the various front ends. And also similarly, storage of session IDs, for example, session IDs or session data. This is commonly implemented. So the notion is these are your 3 web front ends, 1, 2, and 3, and they reference a common MemCache cluster to get the session ID. So let's say the user hits a web server, the load balancer sends them, let's say, to this middle server. The session is created after the user properly authenticates. Rather than storing that session data on one server, you store it in the MemCache cluster that's shared across all 3 servers. In actuality, the key value pair is represented on 1, but you store it in the MemCache cluster so that as the load balancer bounces the user from, say, depending on whatever algorithm's being used, from, say, this box to this box to this box, because they're consulting a common backend for the session ID, then there's no breakage in the application. So storage of session IDs to ensure load balanced sessions are handled without breakage, for example, or without failure, as opposed to, let's just note, as opposed to storage on a single web server. This is a common use of it. And another way, of course, is to store session data in databases, but then that incurs hits to your DB, which will invariably, as your site scales, bog it down versus the MemCache approach. So storage of session IDs can be quite helpful in that particular case. You can also use it to store values that should be incremented across web servers. It could be as simple as, say, product ID, invoice ID, user ID, etc. Any sort of ID that should be incremented. So your users are coming in, hitting different servers for different reasons. Maybe your database needs a sequence ID generator, and because you have multiple front ends, because it's distributed, then you need a means, of course, of incrementing it. So let's just note wherever incrementing of numbers is needed. So, for example, product ID, user ID, session ID, etc. can be shared across multiple servers. And you just use the increment function. And if you need to decrement, use the decrement function as well. That's built in to MemCache in the Python documentation. If you just check in any of the instances, again, help MemCache, you'll see the usage of this particular library, which includes functions for typical operations: add, append, cas in the event the value hasn't changed. And notice each of these support the ability to set timers on them as well. So you certainly can do that. You just specify time equals for a particular value, and it'll time out accordingly and need to be set. So you could have a script that checks to see if a value is there. If not, it sets it and it keeps it going. So It's a simple script, no big deal there. You just import memcache and check if the value is not there after trying to pull it from memcache, then you raise a red flag, for example. So in the normal circumstances, when the values are set, they're set with an indefinite time, so they're always available whenever you query them. So for example, script that checks and refreshes key value pairs. Again, depending on your application will determine, depending on the nature of your application will determine how the values need to vary. So you could have a simple script, something along the lines of, and perhaps we'll write in a separate buffer here. So the path to Python, we import memcache. And once imported, we can then determine what we need to do. So let's say we need to get a particular value from the server, some sort of ID. Let's say session ID. So let's create the object. So create MC object. And that's going to be the string that we've been using all along. Let's find it from one of these windows here. And this will be good. Again, the Python interface is great for prototyping. It's whatever you type here can be written into your script. So that's your object, and once the object is there, and of course, if you check the help, you'll see that there are various exceptions that can be raised for various conditions, such as the inability to create the object and so on. So you're looking for a session ID. So let's say session ID is equal to MCGet session ID. So the trick, of course, is to check whether or not it exists. So if not, whatever this value is, session ID, then we do something. Maybe we print error no key and then do something after, such as setting the value and then printing it accordingly. So let's save this. Simple. This is going to be get set session ID .py. And let's take a look at a free buffer. Let's get a new window going here. That's Python get set. So the key doesn't exist. It's made the memcache connection. So let's set it. So using our commands, MC set, and this is going to be session ID, and its value, let's say, is going to be ABZ9984. And then we'll set it, and then subsequent runs will print it. So if not session ID, do that. Otherwise, print it. We could else it or print it, etc. So let's just go ahead and print it here. We could have an exit run at this stage. And you vary this accordingly. We want to keep this as simple as possible. So it's none initially because it doesn't exist. And you run it again, it's in the cache. There's the value. And you can go to any of these hosts and get that key. So memcget. Let's also just tack on, since we're doing a multi here, session ID. So this will quickly pull this back. Let's see what we've got here. Fname. There's the session ID. It just reorganizes it. We'd sort it if necessary. So that's good. That pulls out nicely. And insofar as timing, well, it's indefinite. So to vary it, just set the time. Time equals after the value. So let's take a look here. That would just simply be time equals, let's say, 30 seconds. And then because it's indefinite, currently it'll always resolve and it will never enter this block. So you'd have to delete the key first. So for example, you could do a delete key from any of these. And let's do an MC delete. And that's going to be session. So that should kill it. And then let's try to pull it again. So session ID is dead. You can pull a key. If it doesn't exist, it just doesn't come back. Now it'll set it with 30-second time when we rerun this. Let's just be sure that it's saved. And let's try it again. So none, but then the second time it's there. Now the timer is going to be set to 30. So if we compare and contrast, just keep watching it for a bit. and then let's rerun it. So it's still there, so it's coming back, and eventually it'll be none, then it'll be reset, so on and so forth. So again, the reason why we're profiling these simple scripts is to show you that this is essentially the framework for using MemCacheD. It isn't much more complex than this. Any code you wrap around this is whatever is needed to drive your application. You need an object, you need to see whether or not your values are there, and if not, you need to set them. And another note is that you tend to do sets or updates or replacements shortly after, or immediately after, we should say, a value has changed. So if there is some sort of behavior in your application that causes value to be updated, let's say the user updates his profile, then that should trigger either a set or a replace, for example, or maybe even add if it's a new value. So notice this comes back as none, and then it's going to be set again for another 30 seconds, and that's the time it'll spend in the cache. So it's a little bit of a Python integration. No need to write any full-blown out scripts, just a little connectivity is what's needed to illustrate the point.